Hello, and welcome to this talk on Safe, Fair and Ethical AI, a practical approach which I hope is useful in your own organisations. This talk has two ambitions. It aims to present a practical framework for organising all the different kinds of questions around risks and mitigations and controls that emerge as we try to make our systems safe, fair and ethical. It also tries to stimulate some discussion around conceptual clarity, which I feel is not quite there when compared with more established disciplines like medicine or information security or civil engineering. A little bit about myself before we get started. I originally trained as a physicist a long time ago. My first job was actually at a nuclear facility. I've worked in technology for 20-25 years, and a fair bit of that in central government, where I saw firsthand the impact of data and algorithms on citizens, on communities. I'm really passionate about supporting and nurturing and growing and the importance of communities, and I've in the past co-organised the London Python meetup. I've established the algorithmic art group in London, which is quite big now. I run the data science group in Cornwall, and I run a children's code club as well. I'm the author of a few books on machine learning. Take a look at them. They're designed to be as accessible as possible. And I also run a business, Digital Dynamics, whose focus is on helping other organisations understand their risks around their use of data, algorithms, development processes, and how they've organised their governance as they try to make sure their products and services are safe, fair and ethical. The last few years have seen a real growth in the adoption of machine learning and AI. They've also seen some real leaps forward in AI capability. However, we've also seen a rise in the number of incidents where data and algorithms haven't been designed and used well. There are lots of examples of these, and here's just a selection. The Home Office was in the news for an algorithm which biased against people of a certain origin, and it was in the news again for a particularly unpleasant story around biasing against people of a certain skin colour. We saw this summer, lots of news and discussion in public as well around the mutant algorithm which unfairly penalised students just for being from a particular region or school. Even large organisations with huge budgets and expertise in machine learning and AI can get it wrong. We've seen, for example, news stories about Amazon's recruitment system, which in effect learned to replicate historic biases. And the scale of social media is something we can't ignore, where even subtle issues with the algorithmic recommendation can have a huge impact on society in terms of polarisation and potentially the spread of incorrect facts. So we know we need to do something about this, and lots of questions emerge. There's lots of guidance around explainability, de-anonymization, human in the loop, data drift, selection bias, lots and lots of things that we should be thinking about, and it can feel like we're sort of drowning in this deluge of questions. So what we need is a way of organising these questions into a framework which makes logical sense, so that we can be sure that we've not left anything out, and it also allows us to compare our work with others. We should also understand that assurance in AI is a relatively new field, and in comparison to more established practices like information security or the disciplines around medicine, pharmaceuticals and civil engineering, the assurance in AI is really very much immature. It's at the starting blocks, so there isn't a consensus or a tried and tested approach. And with that in mind, we're much more comfortable understanding why sometimes there are mixed messages around how we should do this. But the good news is that actually consensus is forming fairly rapidly, and I think we'll be accelerating up this curve in the next year or two. And as an indication of that immaturity, it's interesting that in this field of AI, we don't have a commonly agreed scheme or language for describing how things go wrong in a way that other people can understand as well. And that exists in many other fields and is a sign of their maturity. But the good news is that we can learn from those other fields. There's actually quite a lot we can take from the field of information security, which has been developing over the last 20, 30, 40 years. So where we are at the moment is many governments and national organisations have been in a process of consulting and developing guidance around good use of AI, and it's surprising actually the extent to which a lot of those overlap. So if we look at guidance put out by the US government, Department of Defence over there, the UK's own Turing Institute, NHS, Ada Lovelace Institute. If we look at Europe, the EU itself has put out guidance around the use of AI, and actually I'd say 70-80% of it is in overlap, which is good news because it means there isn't a deep schism or the deep division in how we want to approach what eventually becomes a regulation. And many of us do think that a lot of this consultation, a lot of this kind of guidance will become regulation, because it is clear that the current data protection laws aren't sufficient to protect citizens with respect to the use of algorithms. So in short, our current legislation focuses on data protection, not on algorithmic safety. So let's get started in this discussion of conceptual clarity. What do we mean by it? It means that we really need to be clear, crystal clear, on what our objective is. What are we trying to preserve? With all the work we do, what is it that we're trying to protect or maximize? And in order to make that task easier, it helps to be able to decompose that objective into smaller elements, dimensions, pillars, facets, so that we can work on them in turn and think about them more in a more focused way. And it's important that those dimensions, those smaller elements, are actually orthogonal, and together they complete our objective. This might sound abstract and it might sound perhaps obvious, but actually, lots of the guidance around AI assurance doesn't have that clarity. Many of the things that they talk about in terms of what we should aim to do or preserve are overlapping or are actually subsets of each other, or the picture isn't complete. There is actually a major technology vendor which doesn't include transparency in any of its discussion around AI principles, which is unfortunate. So let's illustrate this idea of conceptual clarity and look at a field where I think it does exist. If you're familiar with it, you'll know that information security is often decomposed into three pillars: confidentiality, integrity, and availability. And they are orthogonal to each other, they are different, and together they more or less complete the questions around information security. And it allows us to think about the controls and measures we put in place in terms of whether they actually achieve information security by covering all three pillars, or whether we perhaps duplicate our efforts or have a gap. So it's a very helpful thing to be able to do, and we should be able to do that with AI assurance. The other really important thing we can do with this kind of clarity, and it's really important in business, is to be able to provide justifiability, traceability from controls all the way up to our overall objective by drawing pictures like this, by saying we've implemented a control or a process or a mitigation and it supports availability, which is a part of security. It also allows us to have discussions around proportionality. Should we do it? To what extent should we do it? How much money should we spend on it? What disruption should it be allowed to cause? And actually, as part of the healthy debate around what is information security, some people over the years have proposed a fourth pillar, non-repudiation. And that's positive and healthy, because what it means is we are constantly thinking about what that decomposition should be, and whether actually we've been missing out some risks and not mitigating against them properly. So this kind of updating and challenge is good, and we need to see that in this practice of machine learning and AI. So let's go back to this field of machine learning and AI and ask ourselves, what is the overall objective? What are we trying to maximize or preserve? Is it privacy, or does that belong in information security? Is it transparency? Is that the overall target? Should it be something like explainability? Perhaps it's accuracy, because a system that's inaccurate is going to be unfair to people. And this debate is vibrant at the moment. I wouldn't say it's settled, but consensus is starting to emerge. And we should continue doing that, actually, because people are still publishing guidance where some of these themes are actually not orthogonal, they're subsets of each other, or there's gaps. As I said earlier, in some of them, transparency is missing. As a result of our own work and quite a lot of discussion and debate and taking part in kind of virtual groups and workshops where we really bash out and kick these ideas to really test them, we have our own a consensus that I think is right, but the debate will continue, and the answer that we think is right is this. We think the overall objective is trustworthy systems, and you can disagree with that as an overall objective, but we found this to be a really helpful top level objective. And underneath that, we didn't want too many pillars and facets, and we've managed to narrow them down to 3 or 4. Fairness, which is a fairly broad term, which we can talk about a little bit more in a minute. The idea that these systems treat people equally, don't do any harm. Transparency, because if we don't understand how those things work, if we don't know what they're doing, how can we really trust them? It's hard to trust something if you can't see it. And an important part of that is that transparency has to be understandable. What we see has to be understandable. Accountability is really important. We've talked about that in terms of being able to respond appropriately when things go wrong, being able to be accessible to those who are perhaps the victims of a system gone wrong. And privacy is an interesting one, and we originally didn't want to include it because it really is, usually sits under the umbrella of information security. However, we have found that there are, a significant class of algorithms and data processing which de-anonymizes data in a way that the subjects of that data are perhaps not aware of or didn't consent to. So that's become so significant that it's one of the 4 pillars. And actually lots of the themes and objectives that people will raise and do care about can fit under these 4 pillars. So equality is really important to people. Some people care a lot about technical accuracy, whether a system can achieve good predictive behavior, for example. That can fit under fairness, because if it's not behaving accurately, it's not behaving fair. Others will worry about broad questions around no system should harm anyone, should respect human autonomy. These can fit under the umbrella of fairness. Similarly, questions around public insight into how systems work naturally fits under transparency, but so do those concerns around whether it is explainable fits under this umbrella as well. In our experience, many organisations are actually very good on the technology and the software development, but perhaps a little bit weaker on accountability, and that raises questions around whether that accountability is accessible to the public or to the subjects of their kind of products and services, whether that accountability is responsive, but there's an actual cost of doing things wrong, and if there isn't a disincentive, that can be an issue. And as we've said, this question of privacy, the main issue around that with respect to machine learning and AI is de-anonymization. So let's get started. Step one is to build a map to scope out our systems, and we do that by drawing boxes on a piece of paper, mapping out data sources, data flows, the technology and the algorithms we use, and that's very comfortable for many of us, but actually it's not sufficient. We also need to include the development process in that, because that can make a significant difference to how safe, fair and ethical our systems are, and we'll see more about that in a minute. And we can't stop there. We also need to include people, because data is often about people. The systems are often making decisions, or their outputs are affecting people, and there are people in your organization who are developing these systems, are responsible and accountable for them, and they need to be part of this picture that we draw out. So the next step is to establish impact. What is at stake when things go wrong? What's the fallout? And surprisingly, this is we find people don't do this. It's amazing, because without doing this, you can't calibrate your response. You need to understand what is at stake in order for you to justify the work that you do to prevent it going wrong. So you need to understand what happens to your subjects if the system goes wrong, and there might be several ways in which it goes wrong. You might be recommending which shoes to buy next, in which case if you get that wrong, there's no harm to somebody's health or life. It might be inconvenient, there might be a little bit of a financial cost to yourselves. If you're making systems that are medical in nature, so recommending medication or diagnosing disease, the impact of getting that wrong is very high, and therefore that has to drive the resources and effort into making sure that that doesn't happen, or there is a suitable response if it does. And actually this is something that is overlooked. Even if the output of a system is subtly wrong and is perhaps imperceptible or immeasurable when it comes to one subject, when scaled out to entire communities, the impact can be significant. So it's worth bearing in mind that actually you should look at the aggregate impact, not just narrowly focus on the impact on one individual. Once we've understood the impacts and we know what ballpark we're playing in terms of seriousness, we then establish what kinds of risks apply. And that's where this framework really comes into its own. We can look at the map that we built, the scope, and we can methodically apply those four pillars: fairness, transparency, accountability, privacy, to each of those domains. We can apply it to data, the algorithm, the people involved, the communities involved, and that's an exhaustive and thorough process, and will take some time to do properly. So we won't do that here, but we'll look at just some examples just to illustrate the idea. So for example, you might say, well, how does transparency apply to the algorithms we're using? Do we understand what the algorithms are doing? Are they closed proprietary software where we don't really know what they're doing? Or is the algorithm open? Is the software open source? So who's accountable for the systems that we're building? Not responsible in terms of development and building and testing, but whose neck is on the line when things don't go right. You need to understand who that person is, and that person might not know they're accountable. Do they know what they're accountable for? Do they know what to do when things go wrong? Is there a playbook? Do they practice what actions to take when things go wrong? We don't often see that. And accountability is not just about the person inside your organisation. We need to think about the subjects, the citizens or users. Can they access your organization's processes for identifying when something's gone wrong, to be able to complain or to alert, and then for action to be taken in response to that. That feedback is really important, and you should really be thinking about and testing whether a subject can actually reach your organization, reach the right person, and have the right corrective measures take place, and perhaps compensation as well. Does your algorithm de-anonymize data? As I said earlier, privacy is sometimes seen as a concern of information security, but we have seen actually in bringing data together and using interesting algorithms can expose more about the subjects of those data than they thought that they had given consent to. In terms of fairness, you might ask a technical question such as, is the data biased? Is the data drifting after it's gone live? So we might have tested our system, works really nicely, it's gone live, but then over time the input data is moving. So these are the kinds of questions that we should be answering as part of this process of applying this framework. And there are many other kinds of examples that we could go into, and it wouldn't be interesting here to list out all the different combinations. So once we've done that, once we've kind of established some of those risks, we need to think about proportionate controls and measures that we put in place, and we're now in a position where we can justify them. We know why we're doing them. And here's just some examples just to kind of illustrate the idea. It might be that the output of our system is so life-changing and potentially important to an end user, to a citizen, that actually it's only right that there is a human in that loop, so it's not an automated process. A person, a qualified person, uses the output of our automated system and is there as the person that brings the information on news to the citizen. That can be justified. Now, what we said earlier around understanding impacts, if we're recommending which shoes to buy next, that's not justified. You don't need to do that. Whereas if you've made a diagnosis and the results are potentially good or bad or unclear, this is justified. And there's another scenario where a human in the loop makes sense. So for perhaps intermediate impact situations, you might have a machine output where it's not certain what the correct answer is. It's not certainly A and it's not certainly B. It's something in between, and we're not really sure. And it can make sense then to flag to a human to say, look, the algorithm isn't certain about what the right answer is. We need a human to get involved. And that's a very good example of human in the loop. It might be that actually you justify shutting down your entire system if it's producing very wildly out of range answers, or people are starting to complain. That can be justified. And again, your justification is based on understanding the impact. In fact, we don't often see this, but more organizations should do it. Monitoring the input where actually your input is drifting and is nothing like the data it was trained on or expected, and you should be setting up automated sense checking of your data, and if its quality is degrading or its variances all over the place, you might decide to alert or stop the system rather than proceed with unsafe data, garbage in, garbage out. In other situations, it's really important to be able to justify the decisions that your system made, and that and what is at stake can justify the expense and effort of implementing a fully auditable and repeatable archive of your development process. Again, if you're recommending shoes, that perhaps isn't justifiable, whereas if you're recommending medication or health treatments, and you can see yourself ending up in court or another process where you have to be able to justify how your algorithm was trained, on what data, what the parameters were, and why you thought it was safe, and to be able to prove that you haven't tampered with that record, and that can be an appropriate response as well. And something else actually, again, that we don't see enough organisations think about is address the risk of groupthink or narrowthink, where the team is very talented, but actually doesn't really understand the context from which the data came or the context of the users. And this is why it's really important to have diverse teams, and particularly representative teams working in your organisation, because some things just aren't apparent unless you have that life experience. So now that we've talked a little bit about this framework, let's compare it to those emerging frameworks coming from those national bodies. And this is a picture taken from the EU guidance, and as I said earlier, it's 70-80% similar to every other official publication. And we can see a lot of the themes are the same. You can see transparency over here. We can see technical robustness and safety, which implies testing, which implies understanding how your systems perform under different circumstances. We've seen here a little bit about privacy, accountability, and I've highlighted here things around items around human agency and oversight, being able to kind of understand the societal environmental impact of our systems. When looked at like this as a sort of a star chart, they all make sense, but actually through the framework that we're proposing, you can see why they're important. You can see that human agency and oversight is important in certain impact scenarios where it is justified that there is a human in the loop. We can also understand how, for life-changing decisions, it's important that the subject has recourse to your governance to be able to correct an error. So you can see how the framework that we're proposing has these objectives in a more logical context. I talked earlier about more mature sectors and what we can learn from them, so let's pick out a few examples of lessons we can learn. So this question of a black box emerges a lot in discussions around AI ethics and understandability or not about how perhaps a neural network or other models work. Actually, many other sectors have systems which are not 100% deterministic. For example, medicine. We don't always know how and why they work. In some people, medicine has an effect which we can't explain. So that doesn't mean we don't use medicine. What we do instead is we build our confidence through testing. We test diversely, we test at scale until we've reached a point where we can say this medicine works in 99 or 99.99% of cases, and we're happy that in a small number of people there will be an adverse effect, but we've also understood what those adverse effects are. So the point here is testing and understanding how a system behaves can in some cases be a good response to the black box problem. If we look at engineering, civil engineering, building machines, we've been doing that for hundreds and thousands of years. We've got quite good at understanding how to build them and test them, and in particular understanding their operating characteristics. When we build machines and tools, we test for the situations in which they work best, which temperature range they work best in, and then how do they start to fail outside that central region. As we increase the temperature or the humidity, does material rapidly crumble or does it take a while to break? This development of operating characteristics is something we need to do more of in the machine learning world. And testing and continuous testing, we are actually quite good at that in software engineering, but actually in the machine learning community, we've too often built systems that we've tested and then deployed and not continuously tested them. So let's look at this question of ethics, which actually is quite challenging for many people in a technical field, because it's very inconcrete. It's very kind of abstract and philosophical and hard to pin down by its nature. If you have discussions with philosophers and ethicists and sociologists, this sort of terminology around, utilitarianism and existentialism and deontological ethics and so on and so on. And it can feel a little bit despairing about, how do we turn that very lively and sometimes wishy-washy discussion into something concrete and practical. And our conclusion really is that yes, ethics can be subjective, and yes, there are many views on it, but ultimately it's a choice, a set of choices that you or your organisation makes, and understanding those choices, being conscious of them, is important. So no organisation is objective or neutral. Every organisation is made up of people with their own experiences and biases and beliefs and so on. And that is, seeps into the technology that we build. If we're aware of that to some extent, we can try and mitigate it. But a better position, and this is what we recommend organisations to do, is to actually be very public and open about the choices you've made, particularly those which are in a grey area. Do we use postcodes or gender as part of our algorithm? Would they perhaps, even if they're not illegal because they're protected characteristics, they might be a proxy for discrimination or kind of treating people unfairly. So being public and open is the best approach, we believe, because it allows people to trust what you're doing, to understand, and also to provide feedback to you, to say, look, we don't agree. And that's where you start to kind of match your choices, your position, your ethical position with where your public or your customers are. And a bit of a motto for us is, design AI for the society we want to be, not the society we were in the past. Because too often our machine learning systems are learning to replicate previous biases and prejudices. Thank you very much. I hope you enjoyed that, and I hope it was useful.